about DC theory? That be next. What can you tell me or someone about resistance? There's some things like what, Mr. Malarius? Okay, well let's kind of turn back the clock a little bit. Before you even do that. There you go. Opposition to current. Yeah, so here's where we're at. What you're stating, that falls in line when we start getting to solving the circuits. Okay, so we keep it at the theory level first. So it's opposition to current, isn't it? Opposition to current. What's the unit of measure? Ohms. We know these things already. This should be the easy stuff because we've been applying this since day one. What can someone tell me about current? Anyone? Bueller? Okay, try again.
It's the intensity of the charge.
I like that word, intensity, because that's where the I comes from, huh? Is in Ohm's law. Intensity, directed flow of charge. That's a really good definition. That's what it is. It's the directed flow of charge. Now, there were other terms that I don't have listed, like charge and Siemens. There's a chart that talks about that. And those two terms, like charge and, well, conductance rather, you don't have to really stress so much about. The big four are right here, which you really have to know. So, current. It's the intensity or directed flow of charge. What about the voltage? What's the alias for voltage? Yeah, EMF, potential, yes. All these things mean the same. How would we describe that? Voltage, potential, just one word. Right, force. Force. There is no test. Star Trek loves. Oh, I guess the Jedi mind trick doesn't work. Force. So, for this simple circuit here, as we learned about schematic symbols too, we got the battery, resistor. Which one of those components would be considered the force? Yeah, the battery. That's the force. That is what's going to drive this. Direct flow charge, which is the current intensity. How much? How much current's in a circuit? Depends on this, doesn't it? Depends on how much opposition. Now the ELOs for this lesson. Mr. Cisneros, for DC theory, what are we looking at? Make sure we're hitting the right things here.
The aid of references selects the statement that identifies the unit of measure for a specified electron quantity to identify the bulk component.
Okay, we'll stop there. And notice that he's saying with reference, supposed to be without the aid of reference. Resistance, the unit of measure was ohms, right?
Yes, sir.
What about current? What is the unit of measure?
Amps.
It's amps. Or amperes. Here. Ohms. What about this? Volts. Oh, yeah, okay. Volts. Yeah, it's working. Now, power came later on. It came later on, like down here. But since it's one of the big four, we'll discuss it now. Power. How would you describe power? A really good, easy definition. Anybody? Power! That's what a resistor does, one of its functions. Mr. Martinez.
Heat dissipated by a component.
How about amount of work done over a period of time? That sounds like that's right. That's what we're looking for. Amount of work. Work over a period of time. Now here's the thing. What kind of work are we talking about? What kind of work? We've got a kick-ass boom box in a truck. It goes out mudding. Anybody do that? Ah, very somebody did. So, when you go to, you put your own stereo in, install it yourself. Anybody install stereo in their vehicle before? Get them big, huge woofers up in the back window. Okay, they're just dwindling down. Elliot or Cameron. What made you purchase a certain speaker? Either a brand or the size. What was it? What do we always think of when we're dealing with speakers? How much? Yeah, the wattage. Hello. Well, that's a good example right there. Because if you want a boom, 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 you got to get that boom, 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 like that. With a little bit more bass in my voice. Boom. Well, where do we get that boom, boom, boom from? A lot of power. It takes a lot of power to do that. So a nice big woofer. So that's just an example. Work that we're talking about. Something's getting accomplished in the circuit. Like the speaker. Hey, I can jam to Justin Bieber and Lady Gaga all day long. My name might not be boom, boom, boom. I get some Black Eyed Peas up in there. Hey. You need to be familiar with these definitions. Units of measure. Power happens to be what? Watts. So you need to know these things. What would I need in a circuit to be considered, hey, it's a circuit? Okay, good. There we go. So you need to have some type of source. What else? Yeah, conductors. Yeah, you need something or the path that those lazy electrons can move about on. Conductors, what else? Yep. That's it. That's what makes a known circuit or a circuit that actually does something. Source, battery, conductors, the wires that it runs on the circuit board, some type of load. There it is.